All right, welcome in. We are in module 13, which is in chapter 12's material. We'll start here with measures of central tendency. So without further ado, let's dive into it. So we'll talk about several different ways of identifying central tendency, or what we call averages, sort of. The first one is the mean. The mean is the sort of average that we think of when we just say average. That is to add up all. This little notation here means you're going to add up every single individual element and then divide it by the number of those elements, right? So we'll take a look at this. Between 1980 and 2019, this bar graph shows the price of a movie ticket for 9 selected years from 1980 to 2019. Find the mean price of a movie ticket for this period, round to the nearest cent. So I'm going to take each of these values. I'm going to take $2.69, add that to $3.55, add that to $4.23, and the next one, and the next one, and the next one. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 of these. So after I've added them all up together, I'll divide it by 9. I'm not going to write it out because it's right here. Each of those added together, the $2.69 ticket, $3.55, and so on and so on. There's 9 of them. I'm going to divide it by 9. But the first thing we'll do is add all of those values in the numerator. That ends up being $52.10. When we divide that by 9, that gives us an average of $5.79. The mean is, and when we look at the mean, we typically will write it as an X with a little bar over it. So X itself represents each data value as it is written here. X with a bar over it is our notation for the mean. But if I have a whole bunch of values that occur repeatedly, rather than saying add up $3 and $3 and $3 and $3 and $3, we can write that in this way here. That we're going to find the sum of each individual value multiplied by its frequency, how many times it occurs. Okay. So if I have a larger set of numbers, I can come back and look at this. So example 2 here, the table to the right shows students' responses to the question, how stressed have you felt in the last 2.5 weeks, on a scale of 0 to 10, 0 being not stressed and 10 being as stressed as possible. The frequency distribution here, we're going to use that to find the mean of the stress level ratings. So each one of these has a value and a frequency. And I can find X times F simply by multiplying the value by its frequency. So 0 times 2, 1 times 1, 2 times 3, and so on. Okay. All the way down to this bottom one, its value multiplied by its frequency. And in fact, we'll just tack on one more column into this table and write that, X times F. 0 times 2 is 0. 1 times 1 is 1. All the way down to 10 times 14 is 140. And I'll add all of these values up. 0 plus 1 plus 6 plus 36 plus 64, and so on and so on. All of those added up become this top part. And then N is the total number. So N is going to be, there was 2 of them here plus 1 of them there. So I'll add that, add that. When I add all of these together, whatever I get there is my N. I think it said it didn't. So we would have to add those by hand. Okay. So there's 151 altogether. If I've added all these together, that's 151. If I add all of these values together, that ends up being 975. So I'll take that 975, divide it by 151, and on average, I get 6.46. Now you should end up with some number in the range, right? Somewhere between 0 and 10. If I ended up with, on average, everyone said 12, I've probably done something wrong. right? And by probably, I mean definitely have done. All right. The next idea of central tendency is called the median. The median is the data item in the middle of each set of ordered data. So if I have a bunch of numbers, I might have like say 2, 3, 1, 4, 9, right? If this is my data set, this is not ordered. I want to order it, meaning put it from smallest to largest or largest to smallest, whichever. 1, 2, 3, 4, 9. And the one that's right smack dab in the middle is my median. So for example, in this set here, I have a set of data, 84, 90, 98, 95, 88. It's not ordered. So the first thing I want to do is order it, which I'm not going to do because they've done it down here. And then we pick out the middle number. So in this case, the median is that middle number, 90. This one's easy to remember. If you think of a road, if there's something in the middle that's called the median, it's legitimately that thing right in the middle, right? Now, with this median, if I have, say, this set of data, 68, 74, 7, 13, 15, 25, 28, 59, 34, 47, we're going to put it into order, which they've done here. So I have this set of data, but there is no middle number. There's 1, 2, 3, 4, 5 numbers on the left of this line, and there's 1, 2, 3, 4, 5 numbers to the right of the line. If this is the case, then you have an even number of data. Then we're going to take the mean of the two middle. So I would take 28 and 34 and find the mean of them, which is to add them together, divide them by 2, because we're finding the mean of two numbers. And then that median of those two, the mean of those two is the median of my set. So my median here is those two divided by 2, 31. So let's look at this here. I have a set of data, 25, 25, 27, 27, 28, 29, 29, 34, 45. They are in order. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. If I have 9 of these, I'm going to take 9 and add 1 and then divide that by 2. So 9 plus 1 divided by 2 is 5. And that is the position that is my median. So that is 28, the fifth value. And you can count these, right? There's 1, 2, 3, 4 on the left and 1, 2, 3, 4 on the right. It is indeed the middle, right? Now, if I have these values here, can I erase? Let me get an eraser out. Can I just erase all of it? I cannot. Oh, I can. Sweet. So on this particular set of data, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I try that same idea, add 1 to the highest value, the highest n number, and then divide that by 2, I get 11 over 2, which is 5.5. And if you end up with something 0.5, you know you're going to have to end up taking the mean value of those two middle numbers, right? If you end up with a nice whole number, that number is your median. If you end up with a 0.5, then you're going to have to take the mean to find the median. So if I have frequency distribution and we want to find the median, right? There's 151 data items in this table, which means it's not, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it's got to be 11 plus 1 divided by 2. So my sixth value, 1, 2, 3, 4, 5, 6. You can't come in here and say, oh, boom, it's a 5, right? Not how it works. We need to consider all of the values and the number of times that they show up. So I have 151 total. So if we add 1 to it and then divide that by 2, it's the 76th position. So there's 2 plus 1 more is 3. Plus 3 more is 6. Plus 12 more is 18. That's supposed to be a plus. Plus 16 more is 34. And I'm just going to keep going until I find my 76th number. Add 18 more. That gives me 52. Probably want to double check these. I'm doing them on my head and I'm terrible at arithmetic. But then I'll keep going, add 13 more, and I get 65. I could probably just cheat. It's almost certainly on the next slide. Plus 31, and that puts me over at 96. Right? So my 76th data item is definitely right here because this contains data items 66 through 96. And so my median is 7, which means if I listed these out, I had 2 zeros, I had 1 1, I had 3 2s, right? If I listed all of these out right smack dab in the, oops, not a 3. I can't change that. Shoop. Right smack dab in the middle is going to be a 7. And I think I could have cheated. Yeah. They listed them out 1 by 1. There's no way I would have done that. My method's better. All right. Comparing the median and the mean. Let's take a look at this example here. 5 employees in the assembly section of a television manufacturing company earned salaries of $29,700, $30,000, $31,000, $32,000, and $33,000 with some change. The section manager has an annual salary of $105,000. So we're going to be asked to do 2 things. The first is to find the median annual salary for the 6 people. So that's the 5 employees plus the section manager. So I'm going to put them in order, right? We're finding the median. That is to say we're finding the middle number. So I put them in order, lowest up to highest, right? And then I pick out that middle number. There isn't a middle number though. And so I take the mean value of those 2 values. So that plus that divided by 2 gives me 32,050, right? Now, if we want to find the mean value of these numbers, I would take them all, add them together, and divide it by 6. And so my mean value is 43,700, right? Which is a value that is somewhere between the top assembly line earnings and the manager's earnings, where if I come back here and take a look at it, that median is going to be right there smack dab middle between the middle 2, right? So these 2 values differ in a pretty big way. If I had instead of these values had just changed this last one, let's say this very wealthy, what is he, the team foreman or whatever he was called. Let's say he makes $1 million an hour per whatever year, right? Then this number doesn't change. It's still going to be the average of these 2 values in the middle, right? So that guy being so much more doesn't have any effect on this, but it's going to have a pretty big effect on this because it appears in my calculation. Instead of 105,000, if I ended up with $1 million here, this would be much higher. So the mean is affected by these big numbers, or ridiculously small numbers as well could also affect it. But the median is not affected by those values. The last one that we would talk about as far as central tendency and averages is the mode. And the mode is the data value that occurs most often in a data set. So if more than one data value has that highest frequency, each of these is a mode, which means you could be bimodal or trimodal. And then if there is no data value that occurs most often, then there is no mode. So an example here, I have this data, 724, 7810. The 7 appears twice, which is more than anything else. So my mode is 7. All right. And the mid-range is found by adding the lowest and highest data values and dividing the sum by 2. Right? So I lied to you. This is another way of finding essential data. We just don't see it very often. But we take the lowest data, highest data, divide that by 2. So an example of that, Newsweek magazine examined factors that affect women's lives, including justice, health, education, economics, and politics. Using these 5 factors, the magazine graded each of 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown below. Find the mid-range among the 12 best countries to be a woman. So we have this. Best places is over here on the right. I lost my marker. That's not helpful. Yoink. Best places is here on the left, and then worst places on the right. So the best places, Iceland, Canada, Sweden, Denmark, so on and so on, right? We made it. Look at us. Yay for us. We're going to take that, and we're doing this for the best places to be. So I'll take the lowest score, which is 87.2, and the highest score, which is 100. Add those two together and divide it by 2. So 96.6. And then if we wanted to do so, poor Chad got a 0, and Sierra Leone 29.0. If I wanted to do this mid-range for the worst, I would take 29.0 plus 0 and divide it by 2, and I would get 14.5. All right. Section 12.3 in our book is measures of dispersion, or how spread out values are. So range. Range is used to describe the spread of data in items in a data set. 2 of the most common measures of dispersion are range and standard deviation. Range is the difference between the highest data and the lowest data value. So on Honolulu's hottest day is 89 degrees. Its coldest day was 61 degrees. The range in temperatures is the hottest, the highest, biggest, greatest value, minus the lowest, coldest, smallest value, and that is 28. This figure shows price per gallon for unleaded regular gasoline over 4 selected years. We want to find the price range. So I'm going to find the highest value. That highest value is $2.79. And then the lowest value is $1.17. I'm really sure what's happening with this pen or paper or anything. But I would just then subtract those. $2.79 minus $1.17. My range is $1.62. And this is almost certainly going to be different if you extend this past 2020, but we don't need to talk about that. So standard deviation is a kind of a big deal. We'll talk about some things to do before then. The very first thing we want to do, we want to find the deviations, right? The deviations are how far something is from the average. So every single one of these is compared to my mean average. And that is just the sum of all of those values divided by n. So for the gas problem, right, we have the $1.17, $1.52, $2.79, and $2.08. We just find that average, that mean value average of $1.89. And the deviation is each data value minus that mean. So $1.17 minus $1.89, and that's a negative number, negative 0.72. Then I'll take $1.52 minus $1.89. And then the next value, 279 minus $1.89 and 208 minus $1.89. And each of these is the deviation of each data value. Once we have those, we're ready to play around with the standard deviation for a data set. So in order to find the standard deviation, step by step here, the very first thing, find the mean. You need to know that X bar value, right? That means the mean. Once you've done that, you're going to go through just like we just did and find the deviation for every single data value, right? If a data value occurs 2 or 3 times, then you need to count that deviation 2 or 3 times. If it happens 100 times, you need to count it 100 times. So I'll do that for every single one of these. That is to say, a particular X value minus that X bar, right? Once I've found those values, which I'm going to backtrack here, that's these values here. Data item is X minus the mean is X bar. Once I've found those values, I'm going to square each one of those. That is to say, whatever my X minus X bar ends up being for every single data set, I square it. So I should have just a list of positive numbers here. And then I'm going to add all of those together, right? So this notation here means everything that we've written, my X minus my X bar that got squared. This could be my first data value. And I'm going to add that to the second data that was subtract the mean and squared. And then my third data value that was subtracted from this thing, however many there are. Whatever these values that you've squared are, you add them all up. Okay. And then we're going to divide that sum. I really wish I could erase now. I can. There we go. Then we're going to divide all of that by n minus 1. So that's one less item than you have, right? So everything that you got up here, this is the sum of all of my X minus X bars that got squared. I take that and I divide it by n minus 1, right? Notation wise, this is like kindergarten notation over here. Real stats notation is the sum of every single item minus the mean that got squared over n minus 1. And finally, once I have this value, and this is a process, right? This is not something that's, here's 10 numbers, take 30 seconds to do it. It might take you longer than that. Once I've got all of those values, I'm going to find the square root of it, and that is my standard deviation. So again, with this, data item should just be an X, mean would just be an X bar. And that would be our notation here. So let's go back to our gasoline example. We found the mean already to be $1.89. In the previous example, we also already found our deviations. So we're going to use those values, and then we'll just square each one. So I'm going to backtrack quite a bit here. Somewhere it was here. We found these deviations. My deviations squared are just going to be like negative 0.72 squared and negative 0.37 squared and 0.90 squared and 0.19 squared, right? I just square all of them. So that is, okay, it disappeared. Looking like this, negative 0.72 gets squared, that's 0.5184. Negative 0.37 gets squared, that's a positive, right? When I square a negative, it goes positive, and I square each of those. And then I'm just going to add all of those up. So this plus the next one, plus the next one, plus the next one. And that gives me 1.5014, right? So this value here is the sum of all of my x minus x bars squared. The next step after that is to divide this by n minus 1. There's 4. If n equals 4, then n minus 1 is 4 minus 1, or 3. So we see that happening here. I divide that value by 3, and the result of that division is 0.50. And so all of this is now equal to 0.50. The next step is to square root this thing. So the square root of 0.50 ends up being 0.71. So we would say that our standard deviation is 0.71. Now, this is the standard deviation of a sample. So typically we call that S. So we could say S is, and it's usually a lowercase s. That looks capital, but it's supposed to be lowercase, is just 0.71. And if we have more information, you'll also run into this little doohickey here. That looks bad. It looks more like this. That is sigma. It's the Greek letter for an S. This corresponds to a population standard deviation, where S is the standard deviation of a sample. The difference meaning I would have to have evaluated every gas price everywhere in order to call it a population, right? Okay. That's it. It's a lot. I know it's a lot, but take your time, go through the material, and pop any questions in the discussions or email, and I will see you guys next time.